Example 7, radioactive iodine isotope with a half-life of 8 days is used for the treatment of thyroid gland cancer. Ooh, thyroid gland cancer. I have hyperthyroidism. Thank God I don't have cancer lah. Okay, this is actually a new knowledge for you. If you don't know, what we have hyperthyroidism and we have hypothyroidism. So actually I'm diagnosed with hyperthyroidism, and the treatment is, some people can accept the treatment for a radioactive iodine. So I think if I'm not mistaken, they would ask you to drink this radioactive iodine untuk the treatment of your thyroid gland lah. If you don't know what is thyroid gland, this is your face, this is your neck. So we have something that kind of feels like a butterfly, that is your thyroid gland. So if you are able to see, my thyroid gland is actually goiter. Actually, that is, macam mana dia bengkak. Goiter is a term, is this a medical term which tells yang kau punya gland ni bengkak lah. Okay, so if you see me in class, my neck is actually, dia bengkak lah, dia besar. So that is a symptom of your thyroid gland producing more hormone ataupun less thyroid hormone. Okay, now you know. That is just a knowledge that I want to share with you lah. Okay, right, so a certain sample is required to have an activity of 8 times 10 to the power of 5 becquerel at the time it is injected into the patient. It is injected, you don't drink it. Sorry. Okay, so we calculate the mass of the iodine present in the sample to produce the required activity. Now, if it takes 24 hours to deliver the sample to the hospital, what should the initial mass of the sample be? And what is the activity of the sample after 24 hours in the body of the patient? Okay, so this one given is the half-life, which is 8 days. Convert it into second, you'll get 6.91 times 10 to the power of 5 second. Then the initial activity is 8 times 10 to the power of 5 becquerel. Okay, so we calculate the decay constant terus lah, supaya we can use it in our question. So this is going to be equal to 1 times 10 negative 6 per second. That is the decay constant. So the mass of the iodine needed to be present in the sample to produce the required activity. So we know that A naught is equal to the decay rate. This is the initial, and we can also write it down as negative lambda N naught. Okay, so from here you can then calculate the number of nuclei. So you get 8 times 10 to the power of 11 nuclei. From here you will then calculate the mass. So that is N over Na times with the molar mass. You will get 1.74 times 10 negative 10 gram lah. That is the mass of the iodine. And then question B, it takes 24 hours to deliver. So 24 hours, convert it into second, it is 8.64 times 10 to the power of 4 seconds. So we can let N to be the mass after 24 hours lah. Okay, after 24 hours, which is 1.74 times 10 negative 10 gram. Okay, so this is the mass that it needs to be when it reach the hospital. Okay, so dia perlu mass yang ini. So we have to find the initial mass supaya bila dia sampai to hospital, dia dapat reach with this mass. Okay, so we let N naught to be the initial mass. Okay, so we are going to use, I'm sorry, I need to add another paper. So we are going to use the exponential law of radioactive decay, which is N equal to N naught E negative lambda T. So this one, you are looking for N naught. You should get 1.9 times with 10 negative 10 gram. Okay, that is the what do we call it? The mass. Okay, so that is the initial mass needed for the sample to be able to reach the hospital with this weight. Okay, then question C, the time is 24 hours, so we are looking for the activity. So this is 8.64 times 10 to the power 4 second. So we are looking for the activity after 24 hours. So that is just A equal to A naught E negative lambda T. So that is going to be equal to 7.34 times 10 to the power of 5 becquerel. Alright. Okay, so that is on example number 7.